Hello, we are looking at 9.1. We are diving into conic sections. In this first section, we're going to focus on the parabola. A conic section, if you're not sure what that is, it's a curve formed by the intersection of a plane and a double right cone. And you can see here that there's a nice layout of what those can be. So you have parabolas, which are essentially, right, like your those second degree polynomials, but because of the fact that they're relationships, you can actually have one that opens to the left or the right, which we couldn't have when we studied parabolas earlier. We have circles, which you guys are hopefully pretty familiar with from geometry. We have an ellipse, so it's that when you cut the cone on the angle. And then we have a hyperbola, which we're going to spend some time later on talking about that. But essentially, right, it's you end up with two parabolas that mirror each other. Okay, so we're going to be looking at is this idea of what does it mean to be a parabola? Well, to be a parabola, okay, we have a focus point. Okay, and if you're looking at this picture here, you have the green focus point, and then you have this blue line, okay, that is your directrix. And no matter where you go on this line or on this parabola, you're going to end up with the distance anywhere on here over to an edge and then down to the actual directrix. Those two values have to be the same. So whatever the distance it is here, it has to be the same there. Okay, that's the defining factor in what a parabola is. Okay, they all have to be equal distance. So anywhere on here you draw from the green directly over to the part of the parabola and directly down to the directrix, and those two values have to be the same. Now, just like when we studied them before, our vertex is still going to be at HK. Now, your equation, when you have a y equals, so you're opening up or down, is y equals 1 over 4c times x minus h squared plus k. And when you're opening left or right, it's x equals 1 over 4c times y minus k squared plus h. Sorry that one got a little mixed up, so I scribbled that out for you. Okay, now we're going to look at how to come up with these formulas and why they work. But that c value where it says 1 over 4c, c is the distance from the directrix to the vertex. Okay, which would be the same as the distance from the vertex to the focus point. And the direction in which it goes matters. Okay, if we're moving in the positive direction, then that's a positive value for c. If you have to move in the negative direction, that means that it's a negative value for c. So we're going to derive this equation. And the way that we're going to derive this equation is we are going to look at an example and we're going to talk about using the distance formula. Okay, so we're going to use the information it says. It says the equation of a parabola, right? We're trying to find that when you have a focus at 0, 2. So we're just going to go ahead and mark that focus, right, at 0, 2. And then it says our directrix is at negative 2. So I'm going to go ahead and draw a line in at negative 2. Now, we know, right, that the distance, right, from any point on here, on this, what's going to be our parabola, right, has to be equal distant, right? So when we look at this, right, our focus is at 0, 2. That directrix is at negative 2. Right, so a point on this parabola, right? Any point on this parabola, xy, right? And the closest point, right? So let's just kind of look at that. So the distance formula, right? We know is x, right? You have to do your x2 minus x1 squared plus y2 minus y1 squared. Okay, well, we know that they have to be equal between the two. So if we take the square root of x minus 0 squared plus the square root of y minus 2 squared, right? Because that is the point F, right? 0, 2. Well, that's going to have to equal the square root of x minus x squared plus y plus 2 squared. And obviously the square root, right, is the whole quantity. So now because both sides of these, right, are under the square root, you could square both sides, and then that just gets rid of our square roots. Okay, so now on the left side here, this x minus 0 squared is just x squared plus y minus 2 squared has to equal x minus x squared. Well, 0 squared, you don't have to worry about that. So that's just y plus 2 squared. Right? And it's plus 2 there because it was minus a negative 2, right? Because the point on the directrix is going to be x comma negative 2. Right? So if you need to write that down, right? Point, right, your point on directrix, right, is going to be x comma negative 2. So now, right, we have this y plus 2 squared, which we can, right, use our foiling out to get y squared plus 4y plus 4. On the left side, that's going to be x squared plus y squared minus 4y plus 4. So you can now subtract a y squared from both sides, add a 4y to both sides, and subtract 4 from both sides. And that gives us that x squared would then equal 8y. And then to solve for y, we divide both sides by 8. And that would give us y equals 1/8 x squared. So the equation for this parabola that has a focus at 0, 2 and a directrix at negative 2 is actually y equals 1/8 x. And we can go ahead and graph that, right? You can make sure that that's going to give you the parabola that fits this by going into your graphing calculator. You can put in y equals 1/8 x squared, and then you just go ahead and graph it. And so, right, you put it in, you can go to your chart to get a couple of values for it, so that way you make sure that you're graphing it correctly. And then you can just go ahead and plot a couple points. 1, 2, 3. So if we put in, right, 1, well, that's only going to be 1 squared, which is 1/8. So that's pretty darn small, right? So we're like 1/8 and negative 1/8. If you put in 2, 2 squared is 4. That's going to be 1/2, right? You put in 4 squared. That's going to be 16 times 1/8 is 2. So 1, 2, 3, 4, 2, negative 4, 2, right? And that kind of gives you an idea of what this is going to look like. Okay, now the second one, we're going to look at one that opens side to side. Okay, so it says, what is an equation of a parabola with a focus at 4, 0 and a directrix at x equals negative 4? Okay, so our x value is at negative 4. So 1, 2, 3, 4. No. That's very good. Try that again. Okay, that's our directrix. We drop a focus point at 4, 0, 1, 2, 3, 4. Right, so we know, right, this is still going to be centered around 0, 0 because that would make it 4 away. So here, right? We know we have to be at 0, 0 because that would be halfway between those two, and those distances have to be the same, right? So again, right, we're using our directrix is going to be, right, our point on our directrix, right? This time, instead of having to be x -2, right, a point on our directrix is going to have to be -4, comma, y, right? And our focus point, again, is 4, 0, and then the point we're looking at is going to be xy. So when we put this in, right, we have the square root of x minus 4 squared plus y minus 0 squared has to equal the square root of x plus 4 squared plus y minus y squared, right? Again, we can square both sides of this, and that gives us x minus 4 squared. Y minus 0 is just y squared. On our other side, you get x plus 4 squared. Y minus y is 0, so that doesn't really matter. So now we can expand this out. X squared minus 8x plus 16 plus y squared equals x squared plus 8x plus 16. We can then subtract an x squared, add an 8y, and subtract the 16. When you do that, you get y squared equals 16x. But here, right, because the y is what's being squared, we actually need to solve for x. So we have to divide both sides by 16. Now, dividing by 16 is the same as multiplying by 1/16. So we're going to multiply by 1 over 16 times y squared. So we're in that format that we like. Okay, so this is going to be very, very shallow, right? At 4, right, with a y value of 4, an x value is only going to be 1 or -1. So we're going to go to 1, 4, -1, or sorry, 1, -4, right? And that makes for a very, very shallow parabola.